So I'd like to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and we actually have two other Onshape employees on the line with us today. We have Kevin O'Toole, who's a actual part of the FeatureScript team and most definitely a FeatureScript expert. He's here to answer any questions that I can't. He's going to help us with questions in the questions dialogue if you go to the webinar control panel. So we really do have a very much an expert in FeatureScript with us today. Feel free to ask any questions that you'd like. And also on the line is Ethan Rito. Ethan's always with me during my webinars, and he'll help with any questions as well. Now, as you can see from the slide, the topic today is creating a custom feature using FeatureScript. And it's really intended for those that are just looking to create their first few features and trying to get started with the actual code writing process in FeatureScript. And so what I'd like to do is walk you through the creation of two simple features. I'm going to go over those in just a bit. So real quickly, an agenda, just briefly. First off, I want to introduce FeatureScript to those that are not familiar with it. FeatureScript is relatively new for us. It's been out a few months now. And I'm going to go over just a brief introduction of what FeatureScript is. Then I want to go over creating a simple pocket fillet feature for those just getting started. That will get you at least understanding the process and the workflow. And then we'll get into something that's a little bit more complex. We have a simple port feature. And I wanted to find an example that would apply to a broad audience. And so a lot of what I'm going to cover in that simple port feature may apply to a number of different things that you might try to accomplish in FeatureScript. So simple port feature, again, one of the most tricky things about doing a webinar like this is trying to find an example that applies to as many people as possible. So hopefully, these two examples will be something similar to what you're trying to accomplish. If not, I'm going to show you a lot of resources that you can learn from. So I have a lot of great things to point out for those that are just getting started in FeatureScript. Now I have a few miscellaneous tips and tricks as I'm going through this. So I'm just going to kind of litter those throughout the webinar as we're going through things, just little things that can help you get things done quicker in FeatureScript. So let's jump into it. Now, what is FeatureScript? Well, put simply, it's a new programming language developed by Onshape that allows you to build custom parametric features. And the language was explicitly defined, created just for the purpose of building custom CAD features. It's a very powerful language. It is JavaScript based. It's meant to emulate JavaScript or look like JavaScript. It is not pure JavaScript, so just keep in mind it is a language that we developed. But if you're familiar with JavaScript, it should look familiar. This language was built into Onshape since the beginning. It was a core piece of our CAD functionality since the very beginning of Onshape itself. Our own commands, the extrude, revolve, sweep, loft, shell, fillets, and so on, are all built in FeatureScript. In fact, I can show you the code in just a moment for our own native features. We've released the source code for our own standard features. So it's important to point out FeatureScript is really the core of our part modeling in Onshape, and it's used throughout Onshape, not just for your own custom features. Our own CAD features, the buttons you click on every day, are actually running FeatureScript. And I'll show you again some examples of that. But the key thing to keep in mind is it's already being used by millions of features. And so it's proven to be solid. It rebuilds just like how you'd behave, how you'd expect it to behave. It's an important part of the core part studios in Onshape. Will the FeatureScript language be available as open source? And it's important to point out, I'm going to get into it in just a bit, we are releasing our source code for our standard features, and I'll show you that in just a moment. We are publicly releasing the source code for extrude, revolve, sweep, loft, our FeatureScript features that users have been using for a long time now. All right, so moving on, that's just a brief introduction into what FeatureScript is. Now, as I mentioned before, you can start with the source code for Onshape's features. So this is our standard document, and it has within it all of our standard features. So there's the source code for our fillet feature, for example, or extrude command. And all of it's being released under an MIT license. And the reason this is important is it means you can freely access it, you can create features based off of it, and either distribute those freely or even monetize them if you choose to, which means you could write a custom FeatureScript feature and make money off of it. Now, the MIT license is permissive, which means you can take and literally copy and paste source code from our own built-in features. And it's a very valuable way both of learning and building your own variations. For instance, if you didn't care for the way our extrude command works and you wish there was an additional option, you could copy and paste the source code, make your own changes to it, and create your own custom extrude feature. So it's valuable from a learning perspective. It's valuable because you can build your own variations of the standard commands, which a lot of users like, and you can literally copy and paste the code. So I'll get into that in just a second, but the key thing is one of the best learning materials and one of the easiest starting points is this standard doc. Now, one last thing I want to point out is you do not have to write code to use the features. And that's a very important thing when you consider who else may be using your code. So maybe you're writing a feature, but you want to be able to distribute it. Maybe you want other users in your company to be able to access this feature. Any of them can access a shared feature. So as long as you shared your feature with those users, they can add it as an icon to their toolbar. So it's important to point out, you do not have to write code to use FeatureScript features. They can be easily added to a toolbar, either from public documents. Maybe the document has been shared publicly. I'll show you some examples of those. Or maybe you've written an internal feature and you want to share it with those in your company. You can do that as well. So it is very easy to distribute this once you've created it. All right, so let's get started. Now I have two examples for you, and the first one is really just kind of introduce you to FeatureScript itself, the Feature Studio environment, and so on, and that is the Pocket Fillet. Now the Pocket Fillet, like the name implies, allows you to click a face of a pocket, and it will automatically fillet all the associated faces, or all the faces connected to that bottom of the pocket. So the neat thing is it allows you to select all the connected faces very easily and fillet them, and it covers kind of the basics of creating a simple FeatureScript feature. All right, now I do have one more example. We're going to jump back to that in just a bit, but let's get into the actual pocket fillet. So here I have a simple part. It's a simple rectangular boss, and I want to create a pocket fillet feature. How would I get started? How would I know where to start to create FeatureScript? And so one of the first things I want to point out is the FeatureScript documentation. When you're building FeatureScript, this is a doc or a series of tabs that you'll probably always want to have open. To access the documentation, it's under the Help menu. You'll find FeatureScript Documentation. So very important, one of the probably most important references I can give you today is this link to the documentation. Simple videos, there's tutorials, the standard library documentation. So if you're looking for a definition for a lot of these things that you're seeing in FeatureScript, standard library documentation is a valuable link. But also, and I've already mentioned this standard library source code. So I've mentioned we're publicly releasing the source code for our own features. This is that document. So if you open up the standard library source, you'll see the link here. It will take you to our standard doc. This is our extrude command, our fillet command, for example. And you can scroll through all the various pieces, the Boolean command, chamfer command, a lot of these names that you'll recognize. Just keep in mind, these are valuable resources for seeing how things are accomplished in FeatureScript. And this is the source code that we're releasing to you to either build your own variation of or to take and create maybe automation from. It's entirely up to you what to do with it. But again, a full list of all of our part modeling features are here in this standard doc. So again, just to reiterate, the FeatureScript documentation for getting started, you'll find it under the Help menu. Probably one of the most important references I can give you today is that link. As I mentioned, there's tutorials, even one written by our own Kevin O'Toole, who's in the webinar here today, that will walk you through building your first feature. They have definitions for everything. So again, just a really valuable resource. Now, another resource that I'd recommend before you spend a lot of time building your first FeatureScript is taking a look at some of the examples that others have created. And so if you go to our homepage, under CAD, you'll find FeatureScript and a link to a whole lot of examples of FeatureScript. So here's a whole series of custom features that have been created by either Onshape employees or the user community. And the neat thing I want to point out is that all of these are open source as well. So you can take a look at the source code for any one of these features and use it to build your own. So this is another great learning resource. If you wanted to know how the port feature works, which is what we're going to be creating here today, you can click on the link, use it. It will take you to that document. You could even add it to your toolbar if you just wanted to use the command. But more importantly, you can take a look at the source code. Right? So another very valuable resource when you're building your own custom feature. Question that's come up: which solid modeling kernel is the basis for Onshape? That is the Parasolid kernel. That's what Onshape uses. So if I wanted, for example, to extend the extrude command to an offset from surface option, I could copy all the default extrude code and then add the additional thing, and that's fine. Yes, and you could build your own option into the standard extrude command if you want, or into your own custom version of the extrude command. It's important to keep in mind you can't change the standard extrude, the button that's in this toolbar, but you can absolutely create your own button in the toolbar that has that option. Questions. How is FeatureScript better than simply importing a part from the library? There's a number of things that I could use as examples. There's lots and lots of things that you could build into FeatureScript that you wouldn't be able to just using a standard part from a library. These examples admittedly are pretty simple just because of time constraints. You have a lot of capabilities with FeatureScript, even to detect things like the normal directions of faces and so on, that really make it simple to create features, even features that are just simple library examples. It's important to point out, creating library-like features is only one example of FeatureScript. There's lots of things that you could do with FeatureScript that really make it a powerful tool.
And just to add on to what Cody's saying, I think a lot of the power of FeatureScript is sort of the way that you can make features that interact with each other. And so you can have something like the port feature that he's about to build, and you can build that into any part and position it where you want to, but you can also have other features that sort of create the rest of the part. So you can have individual features for, I want this plug to look like this, or I want, this feature to make this particular part of the shape that I want. So you don't have to have FeatureScript being the source of everything that's being created in the Part Studio. You can have a whole bunch of features that all build off of each other that are sort of a lot more reusable, sort of like building blocks for a regular Part Studio that can encompass like a whole bunch of workflows. You can imagine having, all the standard features for your company that are all used to create a bunch of similar feeling parts, but which are all ultimately designed by a person using these robust features that you create.
Right, and it allows you to build it in almost a modular fashion. Correct me if I'm wrong. I mean, and that's something you really wouldn't get with something as simple as like a library feature. Um, Another example I always like to point out is I personally have created what we call a spline feature for straight splines on a shaft, and it will detect the in direction face, so I don't need to select any normal directions. It will detect the diameter of the shaft and then apply the appropriate dimensions based on the diameter of the shaft, and so you can do all this logic that makes it impossible to create incorrect features, makes it very easy to apply them. All kinds of neat things that you can do. And I'm going to get into a simple example of it in just a bit. All right, so moving on, I mentioned again that you can check out any one of these examples, and they're a great resource for seeing how others might create custom features. Inevitably, though, you're going to want to get started creating your first custom feature. And so I want to walk you through the process of creating a Feature Studio, some of the details regarding snippets and how you can simplify the process of writing the code, and then using a custom feature. And we'll use this simple pocket fillet as an example. Now, it's a very easy feature to create. It's important to point out all your custom features are created as a tab within a document. So just like a part studio or an assembly or a drawing or even things that you've imported, everything is a tab within a document. The same goes for your FeatureScript code. And the code itself resides in what's called a Feature Studio. So in the bottom left corner of your document, you'll see a plus icon. This is how you can create new parts or new assemblies. You'll also see an option to create a Feature Studio. This will create a new blank Feature Studio that you can start writing your code in. So I want to stress that there is not a software development kit to download, no separate IDE to manage. The code writing environment is built into Onshape, and it's just another tab within that document. Right? So that's where you'll manage the code. This also means that you can share it the same way you'd share Onshape documents, right? With the big share icon on the top right. You can version control it just like you would version control your Onshape documents. It all behaves the same way. Now, when you first get started with FeatureScript, you're going to get an initial framework of code, but not much else. Kind of a blank slate, so to speak. I do want to point out the toolbar in FeatureScript is very valuable for bringing in common snippets that you may want to use. Many features can be constructed using nothing but these simple snippets. The first one, and probably most important, is the new feature icon. This will bring in the framework for building your own custom feature. Okay. Now, if I select new feature, you'll see that framework added to the tab in your document. Real simple, it defines the feature name. We'll call this tutorial pocket fillet. Right? And I can define my feature. Now, there are two important pieces to any FeatureScript feature. The first is the user interface. You'll see what's referred to as the precondition, and then the functions action. And this is the actual code that runs when you create this feature. So the user interface, as well as the code that runs when you create your feature, are both in this one feature. It's an important thing to point out. There's not a separate space to manage your user interface. So let's get started. Now with our pocket fillet, we want the user to be able to click on a face, and we want them to be able to enter a radius value for their fillet. So I will insert a few snippets that allow me to do this. The first is what's referred to as a query parameter. I want the user to be able to query some piece of an existing part or geometry, in this case a face. So I'll select the query parameter. I can name it face, and you'll see I have a filter here for entity type face. This means the user can only click on faces, and I have a max number of pick as 1. So the user can only click on one face. Now, just below this is the actual definition. You'll see definition.myQuery is a query. As I mentioned before, we're querying the model. And in my case, to make this a little bit more clear, I'm going to change this to definition.face. Right, so definition.face is query. Now, that is the first bit of our interface. Remember, the top box now will allow the user to click a face. Just below that, I want the user to be able to input a radius. So just below this, we'll insert another snippet of a length parameter. I can define a length parameter. We'll call this length parameter radius, and I'll say definition.radius. I'm just trying to name these in a way that allows other users to see what this was and to see what my intent was. So those are the two pieces of the interface. As I mentioned before, you have the top half of your code, that's your user interface, and the bottom half, which is the actual functions action, the thing that it does. We're done with our user interface. The user is going to select a face and enter a radius. But what do I want the actual code to do when it runs, when I create a feature? Now, the first thing I like to do, and you'll find that, much like CAD itself, there is a matter of preference when you're writing code. Some users like code to look a certain way, and this, FeatureScript is certainly not any different in the sense that you can write your own, you can have your own style, so to speak. I personally like my variables defined. So I'll define variable of var face equals definition.face. Right? So all I'm doing is saying the variable face is going to be equal to whatever this user clicked on, and I can say var radius is equal to definition.radius. So now I've defined just those two variables. What I'd like to do next is grab all the surrounding faces of my face that I've selected. So remember, my goal with the pocket fillet was to grab all the surrounding faces and fillet all of them in one shot. Now we can do this. I'm going to define a new variable. We'll call it var faces, plural, equals Q concave connected faces. Q concave connected faces will automatically grab any concave connected faces to whatever, in this case, face or whatever the user clicks on. Okay, so now I've grabbed all of those faces. It's time to do our actual fillet. All right, so I can say op fillet, left click. You'll see as I'm typing it, just to reiterate one more time, as I'm typing the feature, you'll see it gives me options. And the main reason I point this out is because you do not have to memorize the exact syntax of an op fillet, for example. As you're typing it, you'll see it pop up. All you have to do is left click, and it will fill out the framework for, in this case, a simple fillet. So you'll see op fillet, the context of the feature, ID, which is the ID of this particular feature, plus fillet 1, and then I have the details of the fillet. In this case, what entities do I want to fillet, and what's the radius. Now remember, I want to fillet all the faces, which is this case, the concave connected faces, and I want the radius that we specify in the user interface. Now you can actually add more to this if you wanted. So for instance, I can go comma and then tangent propagation and set that to true. Right, so I can add to the feature as well and set things like the tangent propagation in the case of a fillet. But that's really it. In my case, I've defined the face, we've defined the radius, then we said the variable faces is equal to all the concave connected faces to the one the user clicked on, and then we just say fillet all those faces with the radius we've specified. Okay, so last step, and an important one, is make sure to commit before trying to use your feature. That's a very important thing. As you make changes, make sure to commit before you go and test your feature. A very important step. You can use, by the way, Command S or Control S, depending on if you're in Windows and Mac. So there is a keyboard shortcut for it. Makes it much easier, but definitely commit before trying your feature out. So let's move on. Now I want to test this. We've written our first feature, a simple pocket fillet. Now I want to jump in and actually test this out. So I could say Part Studio 1. We'll go back to our part, and I want to try and use my feature. What you'll notice is once you've created a custom feature, a Feature Studio, you'll see an icon in the top right corner of a Part Studio. You hit the drop down and you can choose from feature studios that exist in this document. Remember, you can have more than one in a single document, but in this case, I've created this tutorial pocket fillet, which is the name we gave it a moment ago. I can left click and it calls up the feature. Notice the user interface is already defined, so it looks just like an Onshape feature. You'll see I have the face input where the user clicks a face, and I have the radius value, the two things that we defined in our user interface. So all I need to do is enter a radius. Let's define this as 1/4 inch, and then select the face that I want associated with a pocket fillet. Right? As soon as I click that face, you'll see the radius, or all the fillets are now radius. You see the round corners. So very simple. I hit the green check, and we've created a custom pocket fillet. Some things to point out: the pocket fillet feature is a feature in your feature list. So it behaves just like an extrude, revolve, sweep, loft, any other feature in Onshape. It rebuilds just like any other feature in Onshape. So it is treated just the same as any of our standard features. And to kind of highlight this, I want to make a simple change to this. And let's say, for instance, this pocket changed. A certain amount of time went down, and we decided, we need to add a corner cutout, a hole, for example. So let's edit the sketch. I'm just going to draw a simple circle in one of the holes in the corner here. Let's say 2.5. I hit the green check. The one thing I want to point out is notice the pocket fillet recognizes the change to the previous feature and automatically updates to accommodate for that new circle or the new hole that I added to this pocket. And the reason I bring that up is I wanted to show, it is rebuilding just like any other feature. So if you make a change to previous features that have an impact on a feature below it, a custom feature even, it will behave just like, any other Onshape native feature. Okay, so the features themselves, they can be reordered, they can be renamed, they can, um, have an impact down on further design, or they can have parent-child dependencies just like a normal Onshape feature. So I just wanted to stress that they behave just like anything else. The user interface, is already built in, so you're just adding those simple snippets to define it. So that is a simple example of the tutorial pocket fillet. And again, just those few lines of code are what generates it. Can you use the APIs in the Feature Studio? Right now, the APIs are not publicly available. Those are still things that we're polishing up. I suspect that capability would be there, but I don't want to make any promises until that is released publicly. All right. So, question: can I or will I be able to create toolbars with custom tools for different kind of work that could be toggled, visible, invisible? Organization of toolbars is something we're always looking at. I would definitely say that's definitely something that we could be adding in the near future. Our toolbars are sensitive to things like resizing the window, but we don't have the ability to organize submenus as of yet. All of the icons, you may see them here, custom icons do show up as an icon in your toolbar, and they will collapse as such, if the screen size dictates it. But as of today, we don't have the ability to create like subfolders, so to speak, or drop-down menus of just certain categories of features.
Yeah, and one thing I would point out is that when you do add that a feature from an external document, for instance, what you're really adding that to is your own accounts toolbar. So no matter what document you're going to, if I said added the gear feature to my toolbar, I'm going to always see that gear feature in my toolbar. And as we do go and start extending the customizability of this toolbar, uh, like Cody's been saying, custom features are the same as all of Onshape's native features. So you're going to be able to create a custom toolbar that has, extrude, revolve, loft in it, mixed in with, any external features that you may have created. So whether it's Onshape's features, or whether it's features you've made, or whether it's features that you've found that someone else has made, uh, those are eventually going to be all intermixable. And you can see them, sort of organized in your toolbar right now just as a separate category, but we eventually want to move in a direction that's going to have more customization, and when that happens, like Cody's been saying, everything is going to be treated the same way. Every feature is just a feature, and so that should hopefully allow for nice, easy ways of customizing these things.
Yeah, and to follow up on that, and I mentioned this just briefly earlier, you don't have to write the code. These are commands that others have written that I've added to my toolbar, and they are not specific to this document. I mentioned I can add them, but they are, as Kevin mentioned, throughout all your documents. And so just keep in mind when you add an icon like this to your toolbar, whether it was public or whether someone shared one with you, it's there for all your documents, and you can use it anywhere you like. All right, so let's move on. Now, I have a limited amount of time here. We have just about 30 minutes, and I want to walk through a little bit more complicated example than a simple pocket fillet. I think what a lot of users are trying to do, and admittedly, there's a lot of things you could do with FeatureScript. We can't cover, all of the examples in an hour. What I tried to do was piece together two things that I think simple automation that a user might want to create for their own sake. Maybe I do something and it's a tedious effort and I want to try and simplify it. And an example I have for this is the port feature. And this is actually a feature I wrote a few months ago that simplifies creating SAE ports. The reason I use this feature as an example is because it covers a lot of the things that a typical user might want to do if they're trying to automate their processes. I want to automatically construct a plane, create a sketch lines, and revolve cut at a certain location. And you may be revolve cut, it may be extrude cut, you may be generating planes, but a lot of the process is the same for this feature. And so it has a lot of, it shows a lot of common techniques, I should say. And so just keep in mind, yes, we're going to construct a simple revolve cut port, but you could easily use much of this code to construct your own extrude command, your own custom sweep. Much of this is universal. So forgive me now. I know if there's a lot of people out there looking for a lot of different examples of different things. So I try to choose the one with the most broad appeal. So a port feature, if you're not familiar with it, all it is a simple series of lines that's done with a revolve cut. And in the case of the SAE standard, there's a fixed set of values that define what size ports that you can use. So there's different standards, half inch, 5/16. I could go on and on in the standards. And each one has a fixed set of values that they determine to create a simple, essentially revolved cut. The problem with it is it's a series of 10 lines or so. And to sketch them by hand individually each and every time can be a tedious effort. It also means that placing them can be a tedious effort. If I want to place a port, I need to construct a plane relative to another thing, and then go in and sketch each line individually, and so on. So if this is something I did a lot, it would be something that would be ideal for automation. And this is one of those examples where you can go from 5 to 10 minutes per port to 5 to 10 seconds per port. It really has the potential to save you that kind of time. So consider it if you're doing a lot of tedious things. Now, as I mentioned before, this is just one example of where you could use FeatureScript, and there's many out there that may help you automate your processes, may help you create something that you can't create using a standard set of features. So let's dig into it. Now, the port feature itself is a combination of different things. If you think about the process, what I really need is to construct a plane, and what I want is the user to be able to select a point, and I want the FeatureScript feature to construct a plane, lay out all these lines with respect to certain vertices that I define, and then revolve cut those lines. So the process is really the same. You always construct a plane, create a sketch the lines, and do a revolve cut. And I'd like to walk you through how we can handle something like that in FeatureScript. So let's jump into it. Now, the example that I have, bear with me here, is a simpler version of what I showed you just a moment ago. So if you're interested in seeing the complete code, definitely check out the FeatureScript port feature that's on the website I showed you a moment ago. This has the complete code. You can copy and paste from this, and you can get a lot of what I'm going to cover here today. What I'd like to do is create a simpler version of that with only one port size. Right, so no options to choose the ports, but you do have the one port size. And again, the only real difference would be those options to choose. So let's walk through this example. Now, real quickly, just to show you kind of the end result here. My goal is I want the user to be able to click on a point and it automatically insert the plane, the sketch, and do a revolve cut for every point that I click on. And so if we go to the tutorial port feature, you'll see I have an option for points and a depth. And I'll select point. And you can see as I select a point, it creates a port feature at those points. I can change the depth, let's say to 2, and that value will change in the depth of the hole as well. Okay, so just a kind of sneak peek. This is our goal for our feature. So let's create a new Feature Studio. Okay, so I'm creating a new blank slate to start my feature. We'll click New Feature, and we'll call this the tutorial port example. All right. So we've called our new feature tutorial port example. Remember, there's two pieces to the user interface: a series of points, which is a query parameter, and a length value to define the depth. All right, so we'll insert a query parameter. Okay, that's our first that we want to insert. And I'm going to call this points. So we'll call the name points and definition points as well. Okay. Now I want to do one more. I want one more piece of the interface, and that is another length parameter. We want the user to be able to input a length for the depth of their port. So I'll select a length parameter. We'll call this depth, and I'll call it definition.depth. And these are all just renaming the variable names and the actual name that you see in the dialog, just meant to make it easier for those to understand what it is I'm trying to convey, what it is I want them to enter. So that's our user interface. Very simple. You have a number of points and you have the depth. Now, it's easy to move on, but it's important to point out the default snippets may not necessarily apply to what you're trying to do. In my case, I have an annotation named points, but it's looking for faces, right? I want to get rid of that, so we're going to change this to vertex, right? I want the user to be able to click on points or vertices, right? So entity type vertex. And I want them to be able to click more than one. So I'm going to get rid of max number of picks 1. Okay. So very simple again, make sure that the query is relative to what you're trying to select. If the user needs to click edges, make sure to do a filter for that. So one thing you may have noticed me doing, and I kind of do it almost impulsively at this point, is the Format Feature Studios. And that will allow you to align your code if you have any kind of issues with indents, and it just cleans up the code in general. Okay. But now we have our user interface defined. We have a query for points. Entity type is vertices, right? So it's only allowing them to select points. And then we have a depth parameter, which is just a length, right? What length do we want for the depth of the hole? But now we get into the real meat of this. How are we going to define how this behaves? And of course, the first thing I want to do is define just a few variables. Now, the first variable I want to define is depth. So we'll say var depth equals definition.depth. Now, the next thing I want to do is define all the points that exist in my port profile. So just real quickly here, if I jump back to the slide here, this screenshot in the bottom left, you'll see all these essentially what are vector locations. And these are just the points that construct that profile. What we need to do is bring all those together. I think there's probably 11 points in this profile, and put them into one vector array. So one array of vector values. So to speed things up a bit, I have this already defined. And again, the easy way to do this, at least the way I've done it, is literally to construct a sketch and take, simple reference dimensions to figure out the vector values with respect to the center. It's a very simple way to identify the vector values. Once you have them, you can copy or you can insert them into an array. And again, this is not, this is not magic. It's just an array of vector values. You'll see it starts at 0, then it goes to depth and 0, then depth plus a certain amount plus 30,000. So these are just simple XY coordinates in an array. And the neat thing about this is once you've determined your points, all we have to do in FeatureScript is say sketch lines between each one of these points. And I'll show you that in just a bit. Now, if you're looking to follow along, or if you want to do this later on and you're watching the recording, for example, the FeatureScript feature, the one that's publicly available, has this same vector values. Okay, so if you want to follow along, you can copy and paste those. So I'm defining a variable called ports, and that ports is just an array of points. And now later we can go in and sketch lines between all those points, but these values never really change. It's a standard set of fixed coordinates, right? So the next step for us is to evaluate our query, and this is an important step for determining all the details of our points. So I'm going to establish a new variable called var points equals evaluate, and this is another scenario where I'll use the look ahead. We'll say I want the evaluate query of, and then we'll define definition dot points. Okay. So variable points is equal to the evaluation of the query, the points query from earlier. Okay. Again, I'll use the format. You'll notice the format shifts the indent over, just makes it clean, so that when I'm looking at it, it's not confusing. So we've defined the variable points and set it to the evaluation of our points query. Now we can start to define some of the details. For instance, I want to know how many points the user selected. I can say var number of points equals size points. Type, right? So variable number of points, and again, the variable names are entirely up to you how you choose to organize your code, how you prefer it to look, but variable number of points is equal to the size of points. How many points are there? So that's an important number to know, especially when we get into our for loop in just a minute. Then we're going to get into some of the details of constructing our sketch. And one of the things I like to do is give my sketch IDs and the sketch polyline command a specific name. And this is just a matter of preference. This is not something that you're forced to do. But I want to say variable sketch ID is equal to ID, which is the ID of this feature, plus sketch. All right? Again, can't type. So all I'm saying is the variable sketch ID is equal to the ID of this feature plus the string sketch. And this just gives it a unique ID that I can easily query later on, for example. And we'll do this one more time. This time for the polyline feature that we're going to generate in a bit for all of our lines, we'll say var port ID is equal to just a text string of port 1. And again, this is just a matter of preference. This is not something that you're required to do, just something that, for organization's sake, helps me, right? So now we've defined our sketch ID, our port ID. Now we're ready for our loop. And what we want is for every point the user clicks on, remember, they can click on as many points as they want in our dialog, we want to loop through a certain bit of code. So we want what's referred to as a for loop. If you're not familiar with the term, the for loop allows you to loop through given a number of set instances. In this case, I have for loop. If I just do a quick type of for, you can see I can enter the text for my for loop snippet there. And it's real simple. For variable I equals 0, so we're establishing a variable of I, setting it to 0. I is less than the count that we've established. Now in our case, count is number of points, right? So I'm going to copy this code, paste it in, and say as long as I is less than the number of points, loop through, and then of course I increment 1 for each instance of the loop. So simple for loop, if you're familiar with them, it's just going to loop through this code for every point that the user clicks on. Okay? So what I'd like to do next is what is the basic layout of what I want to accomplish? Well, if you think about it, I want to figure out the normal direction of the point. And that's important because I need to create a plane perpendicular to it. I need to create a plane. I need to create a sketch on that plane. And I need to do a revolve cut. So there are a few steps that you may be, in your head. I need to do this, I need to do that. And those are the things that I'm going to accomplish with each point. One of the first tips that I have is when you're doing something like this, make sure to give your sketches unique names. In a for loop, it's very easy to create a sketch for each instance of something. Like in our example, we have a series of points. I want to say for every point, create a new sketch. It's important that those sketches have unique names. And what you'll get is a duplicate error. You'll get an error that says you cannot have duplicate sketches or duplicate features. So one of the first tips that I have, and you can do this at the top or the bottom of your for loop, is to increment the sketch ID. Right? So I can say sketch ID is equal to sketch ID plus I, which is the instance. You could say, plus another incrementer, like a simple 1, for example. But sketch ID, it's important to define as you're creating or incrementing the feature. Okay. So let's move on. I may have made a simple mistake. Forgive me. It's very easy as you're going through this to run into an issue where you may have a wrong, for instance, variable name, or I may have something that doesn't increment correctly. A few tips that I have is when you're doing this, if I could type, forgive me. I see a few comments. Everyone caught it there. So I have a variable sketch name. I did not enter that correctly. Just using this as an opportunity here. if I misspell something, you're going to get a warning. A tip if you mouse over it is to give you a bit of feedback on that warning. So I've got variable sketch ID not found, which is an indication that I didn't define it earlier. So simple mistake, but a tip for those getting started, you do have the warnings there that will appear, and they appear dynamically. You don't have to commit or save or anything like that. So I've incremented my sketch ID. Again, it's important to avoid duplicate sketches. In cases of for loops, you may be doing it many times, and you can't have the sketch name for each instance. Then we need to grab the individual point within the array of points. We have this definition.points, which is just this big array of points. I need to grab the first instance of it. All right. So the first thing I'm going to do there is var point is equal to points and then the individual instance, or I. Okay. So point instance, and that just grabs the individual point from within the array. Then I can grab the owner plane of that point. Remember, we need to know the normal direction of the point to insert a plane perpendicular to it. So I can say var owner plane is equal to evaluate, so EV, and just a tip, if I scroll down here, I can say EV owner sketch plane, and that will grab the plane of the entity that I'm selecting. In this case, I'm selecting a point. This will return the plane for that point. Okay, so you'll see var owner plane is equal to EV owner plane context and then entity, whatever my entity is. In this case, it should be point. Okay. That will grab the owner plane of the point for our feature. Now what we want to do is grab the coordinate system associated with a plane. So every plane has a coordinate system associated with it, and we want to reference that to create our new plane perpendicular to it. So I'm going to establish another variable, var csys, this is my variable name, equals plane to csys. So you'll see a function in there called plane to csys, and then I can select or use owner plane as the reference. Okay, and so now I have a coordinate system that's referencing the owner plane. And the neat thing about that is now I can reference the x-axis, the z-axis, the y-axis of that particular plane. Now, why is this important? Well, now we need to create our plane. And remember, our plane is perpendicular to it. And I also want the plane attached to the point that the user clicks on. So the next step, define a vertex, define the location of the vertex the user clicks on. So we'll say var point vertex. Okay, call this var point vertex is equal to, again, EV, evaluate, vertex point. And so that will do an evaluation of the vertex point you click on and return coordinates. And those coordinates can now make up our plane. Right? So we'll say var point vertex, and I want the location or the coordinates of the point. Okay, so this will return the coordinates, which we can then use to construct our plane. So there's point vertex. The next one, the next step is to actually create our plane. Now, in this case, it's very simple. We'll say var sketch plane is equal to plane. Right, so create a plane function of, and we're going to use point vertex, right, using that location, that coordinate as the origin, comma, csys dot x-axis, comma, csys dot z-axis. So I'm constructing a plane that's at the coordinate of the point the user clicks on, but referencing the x and z axis of the plane we referenced with our point. And the reason that's important is that will create a plane perpendicular to the one the point is sketched on. And that's easy for you to then go in and create your Revolve profile on that. Right? So we'll close this out. And so now we have our sketch plane. Our sketch plane is equal to plane of the point vertex, csys.x and z-axis, again giving us that perpendicular plane. Now that we've created our plane, we can start our sketch. Right? So we'll say var sketch equals new sketch on plane. Right, so I type new, you'll see here, new sketch on plane, left click, and now I have my snippet to create a new sketch. Okay, so there's var sketch, new sketch on plane, context, ID, and then the plane, which in this case should be sketch plane. Okay. So I'm taking the sketch plane we constructed, I'm creating a new sketch on that plane. Pretty simple. Now, let's move on. The next step is to sketch our polyline. And essentially, what we want to do is we want to sketch a line between each one of these vector coordinates. And so there's probably 8 or 9, 10 lines that we need to construct between each one of these. Notice, if you look closely, that the last vector value and the first vector value are the same. This will create a closed loop that we can extrude, revolve, sweep, or loft. So an important step, if you're constructing a closed contour like this, make sure your start and end points are the same, and when you create your polyline, it will close the contour. Okay. So we want to construct lines between each one of these points. That's where sketch polyline is useful. I can go sk poly, and you'll see sketch polyline. And what I want is to use the sketch variable we created here. I want to give it the name port ID, and this is just for my sake, for organization. I want to call it port 1, and then we define the points that we want to sketch between. And you'll see the snippet that I've selected just brings in a series of standard vector values. What's nice is I can then just take my ports variable, which is the same thing, just an array of vectors, and insert that in. Right, so I can say sketch polyline, the sketch variable, which is the new sketch we created. This is the name of the sketch polyline, sketch between all these points. Okay, so real simple, and that will actually construct a closed revolve profile of my port. And it's just going to construct lines between each one of these vector values in the array. Okay. All right, so moving on, let's get into the actual revolve. Now, before you finish any sketch, as you're constructing geometry with sketch, make sure when you're done to select SK solve. Okay, SK solve, and then sketch. Okay, that will solve the sketch and make sure that it's visible in the graphics. Okay, real quickly there, jump out. Okay, here we go. SK solve. Okay, so make sure to solve the sketch. Now we've actually reached a point where we can define, we can actually test this feature. We can go in and create a simple sketch based on a point. And so you don't necessarily have to go all the way through to the finished feature to test it out. I can commit, and if I did things right, I should be able to go back and select a point and have it insert a sketch. And that's the point we've reached at this time. So we'll say tutorial port example. Let's select a point. And if you look really closely there, you'll see our sketch is now being constructed. Right? So this is the series of vertices, and it's just sketching lines and creating that profile that we need. And to test things, we can enter the depth and try out different values. So far so good. Everything is working. Again, just kind of highlighting that you don't have to have a finished example. Now, the next question that often comes up is, what about things like troubleshooting your code? One of the biggest tips that I have for you is printline and debug. The reason I bring these up is they're very valuable for testing things out. Let's say, for instance, I want to verify how many points the user clicks on. Well, I could go print ln and then just enter my variable name, number of points. Right? What this will do, if I commit, go back and test it, is you'll notice in the FeatureScript notices, a very important bit of the interface, you can select FeatureScript notices, and you'll see it says 1. Right? So it's reporting back. It's just a simple print line, but if I select another point, you'll see now it's set to 2. Okay? So just keep in mind as you're going through and creating this that you can do simple print lines and figure out if you're getting the right thing, if you're going through and testing the right thing. So that's a simple print line. Now, the next one I'd recommend taking a look at is the debug function. And the debug function will allow you to do a lot of different things. Now, for the sake of time, I'm going to jump ahead just a bit in terms of writing the code, just to get a more complete example. But I want to show you where debug can be particularly helpful. So we've created our sketch. And one thing I need is, for a revolve, I need a rotation axis, right? I need to define something to rotate about. So what I'm going to do is insert a line referencing what we call sketch entity query. So I have var axis query is equal to sketch entity query. This will query a sketch, in this case, sketch ID. The entity type is edge, and I'm grabbing a specific line within that sketch, in this case, line 0. Line 0 is my very first line and also the line that I rotate about. The reason this is important is as we create a revolve, we need to reference that line. Okay? Now what I want, and this is just tying back to some of the questions before, you can create things like separate functions within your feature script. So I want a separate function for the Revolve Cut. And just real quickly here again, if you're looking for the example of the code, check out the finished example. I'm just going to paste in a simple function. And this function, Revolve Cut, queries the sketch region, okay, of sketch ID, and then does a simple revolve. Remove is the operation type, so cut, of sketch query, referencing axis query, which is this variable we established a second ago, and revolve type one direction, 360-degree revolve. So just the standard options associated with revolve. And all my function does is it grabs the sketch region and does the revolve. Okay. So the only thing left for me to do is to call this function from within my document, right? And so, or excuse me, from within my initial feature, I should say. So I can, again, we'll just do a quick copy and paste. There is the Revolve Cut. So I'm calling the Revolve Cut function, context of the current feature, ID of the current feature, sketch ID, that will allow me to grab the sketch, and then axis query will allow me to pass the query over and rotate about that. Okay. Now, the reason I bring these up is, of course, we're finishing out the feature here, but more importantly, you can do things like a debug. And debug is very valuable when determining, do I have the right entities selected, for example. So keep in mind, debug, and then you'll see open and close parentheses with context and the variable name will give you a lot of information, right? So if we do a commit here and I jump back into this, let's go over a simple example. So points, let's like that one. Now, as I go into the FeatureScript notices, you'll see it query resolves to nothing at this point. Now, what I want to do is go through and figure out, okay, what is the query related to, and so on. What is this supposed to be doing? And an easy way to troubleshoot this is with this debug. So let's jump into another example that I have finished, and I can find, we'll paste that same line, debug, okay. And when I jump back into my document, let's create a tutorial port feature. I select the point. What you'll notice as I go through is I get a lot of values or information about the faces or entities selected, right? So I already have a few features here. Let's just delete this one and create another tutorial port feature and select my point here. And again, you'll see if I go into the notices, FeatureScript notices, query resolves to one face. So it's giving you a specific answer to what it is that you may be querying for. In this case, I've created a query of a sketch region. So if I jump back into my code here, I'm querying for a sketch region, sketch ID, which is the sketch we passed in from earlier, and I'm doing a debug of that, right? And so that debug will return all kinds of relevant information to the feature that you're referencing. So in terms of debugging, print line and debug, the two I just showed you a moment ago, are the most valuable. And as you're troubleshooting and trying to figure out what's going on, definitely check out Printline Debug. So we are literally just out of time. Let's jump back real quickly here. So just to iterate what we've done, using FeatureScript in this example, we constructed a simple plane. We created a sketch on that plane. We sketched a series of lines using SK Polyline, and we created a function to do the Revolve Cut. Okay. So simple examples, but the main thing I want to point out is just kind of the ease of use. You can easily construct a plane. You can query other things from the model and use them as references. All kinds of very cool stuff. So that is what I had planned. I don't want to go any further over time than I have to. So let's jump back into my slides here. I want to say thank you, everyone. I know there are a lot of questions that are still out there, so stick around. I will answer those questions. But that's it, everyone. Thank you, and have a good day.